So what's up guys? Good day, isa gabi na. So I'm Gabriel Escuyos. So this is the answer of my quiz.
Part 1, number 1. Draw the power flow of the DC generator. So this is the power flow of a DC generator. First is the mechanical input, which is the power in. Output of the driving engine. Next, while going to electrical power output, there's an iron and friction loss. Then, power developed armature, which is Eg times Ia. Another loss, which is the copper losses. Summation of I squared times R. Then the final one, the electrical power output, which is PO is equals to VL times IL. Part 1, number 2. What are the two methods in improving commutation? Explain each for one sentence each. First is the resistance commutation, wherein we can improve the resistance of the brushes. Next is the AMF commutation. In this method, a reversing AMF is produced to neutralize the reactance voltage in short circuit coil. Part 1, number 3. What refers to the change in terminal voltage between full load and no load? Voltage regulation. What is a voltage regulation? Particularly power engineering. Voltage regulation is a measure of change in the voltage magnitude between the sending and receiving end of a component, such as transmission or distribution line. Part 1, number 4. Enumerate the 5 reasons of operating generators in parallel. First is continuity of supply and maintenance. A parallel connection is more favorable for repair and periodical maintenance work. It is easier for maintenance when smaller individual generating units are used, since we can schedule the maintenance of each unit one after the other without affecting the continuity of power generation. If instead it was a single unit, then an entire shutdown would be required for maintenance. This would drastically affect power demand during the duration. Next is efficiency. Efficiency versus load curve. Generator efficiency is maximum when the load is 100%. So the generator unit must run on full load. A single large unit would be uneconomical for lower loads. But with smaller individual units, we can add up or switch off the generator's units as per the load requirements in order to meet the maximum efficiency. Then, expansion plans. In order to expand the capacity to 700, suppose the current capacity of a power plant is 500 megawatts. In order to expand the capacity to 700 megawatts, to fulfill the rising future demand, it would be costlier to replace the entire setup and purchase a bigger unit. It would be more economical to buy small individual alternator units which can be added in parallel to the bus bar system in order to reduce the initial capital investment. Next is, another one is size of alternators. The higher the rating of the generator, the bigger the size of the setup will be. It is very difficult to manage a single large alternator which may range around 1000 MVA or more. If we are using small individual units connected in parallel, it will be easier to maintain considering its size. Then the last one is maximize power system reliability. If any of if any one of the generator running in parallel, it's tripped due to fault. Other parallel generators in the system will share the load, so the electrical system is not interrupted by the tripping of one alternator. Only when the shared loads do not make other alternators overloaded. Part 1, number 5. What are the requirements in order to successfully operate generators in parallel? So I have some requirements or needed in order to successfully operate generators in parallel. So first, the terminal voltage must be the same. So para mukuan siya, each terminal of the generator must be the same. Next is the polarities of the generator must be identical. So we must check first if the polarities of the generator are identical. The last is the change of voltage with the change of load must be the same character. So before you change the voltage, you must change also the load because you need to have the same character for the load and the voltages. Part 2, number 1. Two shunt generators are operating in parallel and taking equal shares of 2400 ampere, 230 volts bus load. The rating of the generator are as follows. Percent regulation, where generator 1 is 3 and generator 2 is 4. Kilowatt rated power, for generator 1 is 500 and for generator 2 is 600. Rated voltage, generator 1 250, generator 2 250. If an additional 600 ampere load is connected to the bus, determine the current delivered by each generator at this condition. So this is my solution for number 1. Generator 1. Change of current rated sub 1 is equals to power rated sub 1 over voltage rated sub 1 is equals to 500 times 1000, wherein the power is rated as kilowatt, so times 1000 over 250 is equals to 500,000 over 250 and equals to 2000 ampere for the change of I rated sub 1. For generator 2, change of I rated sub 2 is equals to P rated sub 2 over V rated sub 2, wherein P rated sub 2 is equals to 600 times 1000, wherein 1000 is a kilowatt rated, so 600 times 1000 over 250 is equals to 600,000 over 250 equals to 2400 ampere. First, find the change of I sub 1. So I sub 1 over, find the change of I sub 1. Change of I sub 1 over change of V is equals to I rated sub 1 over percent VR sub 1 V rated sub 1 is equals to 2000 over 0.03 which is the percent V times V rated sub 1, which is 250. The change of I sub 1 is equals to 266.67 sub V. Then find the change of I sub 2. I sub change of I sub 2 is equals to change of V is equals to I rated sub 2 over percent VR sub 2 times V rated sub 2. So 2,400 over 0.04 times 250 for the V rated sub 2. So change of I sub 2 is equals to 240 change of V. So change of I sub 1 plus change of I sub 2 is equals to change of I. So 266.67 change of V plus 240 change of V is equals to 600. So which is the 600 is the change of I. So change of V is equals to 1.184. Then find the the current of generator 1 and is equals to current of generator 2, which is 2,400 over 2. So the current is 1,200 ampere. Solve for the new current of I sub 1. So I sub 1 is equals to 1,200 plus change of I sub 1 is equals to 1,200 plus 266.67 times 1.184. So the new current for for generator 1 is equals to 1,515.744 amperes. This is amperes. So then solve for the new current of generator 2. I sub 2 is equals to 1,200 plus change of I squared is equals to I sub 2. Change of I sub 2 is equals to 1,200 plus 240 times 1.184. So the new current for the generator 2 is 1484.164 ampere. Part 2, number 2. A long shunt compound generator has the following parameters. RA is equals to 0.1 ohm, REC is equals to 0.05 ohm, and RSH is equals to 120 ohm. This machine supplies power aggregate DC load of 10 kilowatt. At this load, the armature generates 246 volts. Determine the terminal voltage. So first is the IL is equals to PL over VL equals to 10,000 for the power is 10 kilowatt, so 10,000 over VL. Next is the ISH is equals to VL over RSH, wherein VL is unknown and RSH is 120. Then the IA is equals to IL plus ISH is equals to 1,000 over 10,000 over VL plus VL over 120. So this is the EG is equals to VL plus IA times RA plus RSE. Then so wherein EG is equals to 246 equals to VL plus 10,000 over VL plus VL over 120 times 0.1 plus 0.05. So we will gonna use here the FOIL method or the distribution. So distribute 10,000 over VL times 0.1 is equals to 1,000 over VL. Then 10,000 over VL times 0.05 is equals to 500. This is not 5,000. It is 500. Sorry. This is 500. 500 over VL plus VL times VL over 120 times 0.1 is equals to 1 VL over 1,200. Then VL over 120 times 0.05 is equals to positive 1 VL over 2,400. Then this is the 246 is equals to VL plus 1,500 over VL, which is the 1,000 plus 500 over VL. So 1,500 over VL plus 0.00125 VL. This is VL, V sub L times VL para makancel ning 1,000 ang VL sa kaning 1,500. So this is now the new form. 1.00125 VL V sub L squared plus 1,500 minus, so gi-transfer na to dire, gi-transpose na nato. So ma-negative na siya kay positive man siya. Negative 246 VL, kaning VL kay katong gi-times na natong VL kani equals to 0. So ang answer niya, which is 239.44 and 6.26. So voltage may gipangita kaning yung dako, which is voltage load is equals to 239.44 volts. Part 2, number 3. A 4-pole DC generator with duplex lap winding has 48 slots and 4 elements per slots. The flux per pole is 2.5 times 10 to the power of 6 Maxwells at it runs at 1,500 RPM. What is the output voltage? So this is the output voltage formula is equals to PNZ flux over 60A is equals to PNZ flux over 60 MP, which atong himo ang Maxwell into Weber, so nani siya times 10 to the negative power to the power of negative 8. So EG is equals to 4 for the pole, 1,500 for the N, 192 para sa Z, 2.5 times 10 to the power of 6 para sa flux over 6 60 na siya, 60 sorry, 60 na siya, 60 times 2 para sa M, times 4 para sa flux, sa pole. So EG now is equals to 60 volts. Part 2, number 4. A separately excited generator when running at 1,000 RPM supplied 200 ampere at 120 volts. What will be the load current when the speed drops to 800 RPM if current field is unchanged? Given that the armature resistance equals to 0.001 ohm, and brush drop equals to 2 volts. So this is the solution. Eg is equals to Ia times Ra plus VL plus VBR equals to 200 for the supplied current times 0.04 for the armature resistance plus 125 for the supplied voltage plus 2 for the current of brush drop. So Eg now is equals to 135 volts. Eg sub 1 is equals to Eg sub 2 is equals to Eg sub 1 over Eg sub 2 is equals to flux sub 1 N sub 1 over flux sub 2 N sub 2. Assume flux is constant. So constant din siyang flux, wala. 135 over Eg sub 2 is equals to 1000 over 800. So mao ni ang ilahang mga RPM. So Eg sub 2 now is equals to 108 volts. So 108 is equals to 108 is equals to IL sub 2 times 0.04 plus RL times IL2 plus 2. So ang RL na to is equals to 125 volts over 200 ampere. So RL is equals to 0.625 ohms. So nanatay kaning RL. So 108 is equals to IL times 0.04 plus 0.625 ohm times IL plus 2. So the I sub L2 is equals to 159.4 amperes. Part 2, number 5. A DC machine running at 500 RPM, the hysteresis and eddy current losses are 250 watts and 150 watts respectively. Find the speed at which the core losses are reduced by 30%. Assume flux is constant. So P is equals to P sub E is equals to K sub E times N sub 1 squared times flux squared. So mao po niyang sa PH is equals to KH N sub 1 flux times flux. So first is the P sub E is equals atong pangitaon. P sub E is equals to K sub E N sub 1 squared times flux squared is equals to C sub 1 times N sub 1 squared. So nawa ni siya. So 150 is equals to C sub 1 times 500 squared. So C sub 1 now is equals to 6 times 10 to the power of negative 4. Next is the P sub H is equals to K sub H N sub 1 times flux is equals to C sub 2 N sub 1. So 250 para sa kaning P sub H, 250 is equals to C sub 2 times 500. C sub 2 now is equals to 0.5. Then find the power. P sub CO1 times P sub H plus P sub E is equals to 250 plus 150. So the P sub 01 is equals to 400 watts. Now, for the P sub CO2 is equals to 400 minus 400 times 0.3. So the P sub CO2 is equals to 280 watts. P sub CO2 is equals to P sub H plus P sub E. So mao ni ang kuan ron formula bag-o sa PCO2 is equals to C sub 1 N sub 2 plus C sub 2 N sub 2. So constant man ang flux, so wala na tong flux nila. So 280 is equals to 6 times 10 to the power of negative 4 times n sub 2 squared plus 0.5 times n sub 2. So 2 unknowns gapon. So n sub 2 is 3.83.51 o negative 1216.8. So ang kuan na ni ang dako. So the n sub 2 now is 3.83.51 RPM. Part 2, number 6. A long shunt compound generator supplies 100 ampere at a terminal voltage 250 volts. The resistance of the armature shunt field and series field are respectively 0.02 ohm, 50 ohm, and 0.05 ohm. The BHP of the driving engine is 38. Calculate the stray power loss. So, atong ano ng power loss sa stray. So, P output is equals to voltage load times current load is equals to 250 times 100. So, sa P sub 2 at P sub 2 na to is equals to 25 kilowatt. Next is the I sub F equals to V sub L over R sub F, which is the V sub L is equals to 250. Ang voltage load na to niya, ang RF is equals to 50, which is the field and series field resistance sa field na to is equals to 500 ampere mo na ang current sa field na to. Next is the IA. I sub A is equals to I sub F plus I sub L is equals to 5 plus 100. 5 ampere plus 100 ampere is equals to 105 ampere sa atong IA. So, EG is equals to VL plus IA times R is E plus R sub E is equals to 250 plus 105 times 0.05 plus 0.02. So, EG now is equals to 257 plus 257.35 volts. So, mani ang power dev P sub dev is equals to EG E sub G times I sub A is equals to 257.35 times 105. So, the P sub dev is equals to 27021.75 watts. So, now the BHP times 746 is equals to P stray plus P sub dev. So, ang BHP na to, given naman 38 times 746 equals to power of stray plus 27021.75. So, ang power sa itong stray is 1,326.7 watts.